What's going on, guys? Let's look at this problem right here. This question is asking find the solution of the given initial value problem, and here we have a differential equation, and if you look at this one, this is matching with this pattern. This is a linear second order differential equation with constant coefficient, and when we have the linear second order differential equation with constant coefficient, we can use this characteristic equation to find out the real roots. Now let's see what we can get from this one. Here our a value is equal to 1, b value is equal to -6, and c value is equal to 9. Now let's put them in the characteristic equation. This is going to be r square minus 6r plus 9, that's going to be equal to 0. Now you can see this is a perfect square trinomial. You can factor this one like r minus 3, r minus 3. If you multiply this, you will get this one back. So this is going to be the factor, and from this one you can see that the roots are same, right? So when we have two equal roots, the general solution for this differential equation is going to be in this pattern, right? So the general solution for this differential equation is going to be y of x is equal to c1 e power r is 3, so e power 3x plus c2 x e power 3x, and this is general solution for this differential equation. But since we have the initial values given, we have to find the particular solution. To find the particular solution, what we do is we just plug this 0 for x values and see what we get. We have to find c1 and c2 values and plug it in this general solution back. That's the particular solution, right? Now if we plug 0 for these x values, and we know that y of 0 is equal to 1, 1 is equal to c1 e power 0, and this one is going to be 0 because we are multiplying x by this, and if we plug 0 for x value, this whole thing is going to be 0, so this is going to be 0. Therefore we know that c1 is equal to 1. Now we found out c1. Now we have to figure out what is c2 is. To find that one out, we have to use the second initial value, that is y prime of 0 is equal to 2. Now to apply this one, we have to find the derivative of this one. Let's take the derivative. So y prime of x is going to be, since we have e power 3x, the derivative of this one is going to be 3, so we multiply this one by 3, and c1 e power 3x. So this is a chain rule. We take the derivative outside, that's going to be as it is, and inside derivative 3x, that's going to be 3. And then the derivative of second one, this is going to be a product rule because we have two functions of x and e power 3x, so this is going to be product rule. Now let's take the derivative of x. If you take the derivative of x and leave the other one as it is, this is going to be c2 e power 3x. And then we take the derivative of e power 3x and leave x as it is, you will get 3c2 x e power 3x. So this is going to be the derivative of this general solution. Now after we find the derivative, we can plug this one in this equation to find out c2 value. And here we are going to have y prime of 0 is equal to 2, so this is going to be 2. And if we plug 0 for x values, this is going to be just 3c1 because e power 0 is 1. And here also we are going to have just c2 because e power 0 is equal to 1, so this is going to be just c2. And this entire thing is going to be 0 because we have this x value, x multiplying everything, and if we plug 0 for x value, this is going to be 0. So this is going to be just 0. And here we have two unknown variables, but we already found out c1, so we can plug that one in this equation to find out c2. Now this is going to be 2 is equal to 3 times c1, c1 is equal to 1, so this is going to be just 3 plus c2. From this one we can find the c2 value, that's going to be -1. Now we have the c2 and c1 values. Now we can write our particular solution. Particular solution of this differential equation is going to be y of x, and c1 is 1, so this is going to be just c1, instead of c1 I plug 1, so that's going to be just e power 3x, and instead of c2 I plug -1, so this is going to be -x e power 3x, and that's going to be particular solution for this differential equation. And that's how we do this kind of problems. I hope this helps. Thanks for watching.